Hi everyone, it's me. So we just had class and the homework tonight is going to be watching this screencast and then doing the questions that I assign along the way, okay? And so what I want to talk about here is, again, just more on lines and planes and specifically problems that involve equations of lines and planes that really force you to understand their spatial relationship and use vectors, okay? So I know we just finished a problem involving distance between two planes, and I really want to say that I really applaud you all just really just diving into this very new way of thinking about math in linear algebra. It is the jump that you have made from calculus to this is significant, and you've done just really great work, so give yourself a big pat on the back, or if you happen to be with somebody, give them a pat on the back, or I don't know, like a loving tickle or something. I don't know, whatever it is you do to show affection. Okay, so here's a question for you. Let me give you this plane, and this plane looks like this. Okay, and I'm going to ask you this question. All right, so what I'm doing here is I'm actually taking even a step back a little bit and really kind of forcing the issue of your visualization. I gave you an equation of a plane, and before we get to the question I just wrote down, I actually thought of an even more preliminary question. The first question is, let's call this question 2. Okay, so here's question 1. Does this plane intersect the xy plane? Okay, so does this plane, boink, okay, intersect the xy plane? And I want you to answer me yes or no, and then a really clear answer why, okay? Does the plane intersect the xy plane? Go ahead and pause me, and then replay me if you want some hints. So, some hints that I want you to think about, okay? The xy plane is the quote-unquote floor, if we use the analogy of the corner of the room, right? And the x, y, and z axes are where kind of the floor and the walls meet and the two walls meet. So the xy plane you could think of as the floor, right? Tell me, any point on the xy plane must have a value of z equal to what? Yes, z has to equal 0, okay? Give me the components of a vector that is perpendicular to the xy plane. Go ahead, think about it, and then replay me. Okay, I want the components of a vector perpendicular to the xy plane. Okay, maybe some of the vectors you picked, maybe the first thing you did was you visualized and said that that vector would have to be quote-unquote straight up, right? Straight up from the floor, perpendicular to the floor, okay? And maybe you would say that that vector n would have to be something like 0, 0, 6, or maybe you said 0, 0, -3. I don't know. Probably the simplest vector would be 0, 0, 1, okay? All of these are perpendicular to the xy plane. All right. Now here's the question at hand, and I am kind of giving you little hints along the way. If you know that 0, 0, 1 is perpendicular to the xy plane, what is the vector that is perpendicular to the plane in question? In other words, what is n for this vector? And maybe you will say that for this vector, n equals 1, 2, 1. Oops, n equals that for the plane in question. And so now My question to you is, if you know that the vector perpendicular to the plane in question is this vector n, and you know the perpendicular vector to the xy plane is this vector n, and boys and girls, you recognize that these two n's are not parallel, what does that say about the two planes? Very good. The two planes are not parallel, and therefore, the two planes must absolutely intersect. Okay? All right. So now question number 2. So in this screencast, what I'd like you to do is to kind of go with me on these various thought experiments. That's the homework tonight, just to go through this screencast with me. Engage in the thought experiments, try the questions, all right? I'm picking up on class today, just a need for us to kind of have these experiments on our own a little bit more, to have questions that force ourselves to really, really intimately understand the material, okay? All right, so question number 2. Knowing now that the plane in question intersects the xy plane, tell me how those two planes intersect. They intersect in what? I think most of you will say they intersect in a line. In fact, I think you'd agree that any two planes must intersect in a line. And now here's question 3. Knowing that they intersect in a line, I would please like you to find the equation of that line of intersection. And this one I'm going to give you no hints and see if you can use what we've just talked about and answer this question. Go ahead and do that. Hold on, of the line of intersection. Go ahead and do that and then replay me. All right, so, well, you know that the xy plane is the same thing as saying the set of all points where z equals 0. So if z equals 0, what we get is my plane, all the points on this plane when z equals 0 are described by x plus 2y equals 2. And guess what? There is your line. This is the line on the xy plane that is the result of the plane in question and the xy plane intersecting. Okay? Very good. Lovely. All right, here's question 4. Actually, let me write all the questions down and then I'll just replay me, okay? Hold on. Okay, here they are right here. Same plane. Question is, does the plane in question intersect the plane y equals -3? So just to be clear, y equals -3 in 3 space, okay? So again, use the analogy of that corner of a room. If you're in your bedroom, go walk yourself to a corner of the room. And on the y-axis, which will actually go through the wall. And you know what? Let's just make it y equals +3 to make it easier for you, okay? The plane y equals +3. On the y-axis, go ahead and put a tick mark at what is +3 units away, okay? All of the points that in 3 space fall on the plane y equals +3, all right? That plane is going to be perpendicular to one of your walls. Do you understand? Right? And all the points that have points, for example, 3, 3, 7, -2, 3, 12, 0, 3, -42, okay, 6, 3, 6, right? All of these ordered triples, you'll notice they all have y equals 3. And if you try and graph all those points, because they fall on the same value of y equals 3, all right, they're all going to fall on the plane y equals 3. So in 2 space, y equals 3 is a horizontal line. In 3 space, y equals 3 is a plane. So the question number 1 is, does the plane in question intersect the plane y equals 3? And then, similar question here, find the equation of this linear intersection. Go ahead and try those 2 questions, and then replay me for the answers. Okay, so the answer to question 4. Yes, the 2 planes do intersect because the normal vector of the plane in question is not a scalar multiple of. So this notation is not a scalar multiple of this vector, which is perpendicular to the plane y equals 3. Do you understand? Okay, this vector, if you think about it, is perpendicular to the plane y equals 3. All right. Now, the equation of the linear intersection, well, at y equals 3, I just plugged in 3 for y into the equation of the plane. Look what I've got. When y equals 3, x plus 6 plus z equals 2 is the result, or, and here's your equation of the line, x plus z equals negative 4. That is an equation of a line on the plane y equals positive 3. That is the result of the intersection of the plane in question and the plane y equals 3. Fantastic. Yay. Okay. So now I want to show you or talk to you about this. What would you do with a question like this? Okay, here you go. And what's really funny, I'm noticing, is that I keep pausing myself because someone keeps coming in to talk to me, and I keep feeling like I have to tell you, oh, hang on. But then I realize that on your end, when you're hearing this and I pause and replay, it's not like there's any break on your end. So my hold-ons must sound very strange. Anyway, here's your next question. You have the equation of plane A. Plane B, you're told, is parallel to plane A, but passes through the point 3, 8, 1. And plane C is orthogonal to plane A and passes through the point -5, 6, 2. Find equations of planes B and C. Go ahead and see what you can do with this, all right? I'm going to offer you, do I want to give you even a hint right now? The only hint I'll say is, okay, finding plane C tosses you a bit of a curveball. But let's try this. Let's try this on the first time through without listening to any of Miss Yam's hints, and then replay me when you get your answers, and then we'll take it from there, okay? So give it a shot. All right, I'm going to go ahead and find the equation of plane B. If plane B is parallel to plane A, what that means then is plane B, okay, so for plane B, the normal vector is going to be the same as the normal vector of plane A. So n is both orthogonal or normal. By the way, I find myself slipping into that vocabulary word. The word normal or orthogonal or perpendicular, they're all synonymous. So n here is perpendicular to both plane A and plane B. And because plane B passes through the point 3, 8, 1, I then know that by the equation of the plane, which is A times x minus x naught, plus B times y minus y naught, plus C times z minus z naught, this dot product has to equal 0. So that tells me 1 times x minus 3 plus 2 times y minus 8 plus -2 times z minus 1 equals 0. And here is my equation of the plane. You may want to, you may care to go ahead and distribute all this and collect like terms, if you will, and get the equation in standard form like this, but I'm not going to do that. Okay, for plane C. Plane C is orthogonal to plane A. Oh dear. So plane C is orthogonal to plane A. Do you understand? Plane C and plane C and plane A are perpendicular. What that means, well, let me ask you this. What does that mean about the n for plane C and the n for plane A? Tell me what that must mean. If planes C and A are perpendicular, what does that mean about their two respective orthogonal vectors? They must also be what? Yes, n1 dotted with n2 has to equal 0, correct? So those two vectors, I guess I should call this n sub c. How about that? The normal for vector C has to be perpendicular to the normal of vector A. And I just wrote that out here in a dot product form. Okay, you can also write it out. I'll do it out for you. NC is perpendicular to the n of plane A, or what we, or, oh no, oh dear, or this statement, right? So now I want to ask you this question. Here's a little thought exercise. Thought experiment number 45, I guess. I've lost count. In 3 space, everyone listen, listen, listen. In 3 space, hold up your pencil in space. Hold it up at kind of a cockeyed angle, like make it an odd little angle. Your pencil is a vector in 3 space. How many vectors exist in 3 space that are perpendicular to your pencil? Infinite, right? If you held another pencil perpendicular to your pencil, you'd find that you can take that second pencil and like rotate it all the way around. So yes, there are infinite infinite vectors that are perpendicular to that first pencil you're holding up in the air. So what I want to do is I need to find a vector. Let's just call this P, Q, R, okay? And this here is the normal vector of plane C. I have to find a vector, PQR, such that when I dot it with 1, 2, -2, this has to equal 0. And there are infinite possibilities that abound for P, Q, and R. Now, please don't get kind of sassy and say, well, let's make P 0, Q 0, and R 0. No, no, no. 0, 0, 0 is not a vector. 0, 0, 0 is a point. Yes, if this were 0, 0, 0, and I dotted it with this, I would in fact get 0, but that is not at all helpful to me. However, I can say, well, let's do this. I'm going to say let P equal 1. I'll let Q equal 1. Let's see. That gets me to 1 times 1 is 1. 1 times 2 is 2. 1 plus 2 equals 3. Okay, so I'm just going to make that. I don't want to deal with a fraction. So I'm going to make this P equal 1. Let's make Q equals 2. Okay, if P equals 1 and if Q equals 2, then this says 1 times 1 plus 2 times 2 plus R times -2 has to equal 0. And we're going to solve for 0. Oh, bollocks, I get an odd number still. Well, that's dumb. Oh well. R equals 5/2, yeah? Okay, so guess what? I have my vector right here. The vector n. The vector n for my plane C, so the vector n for plane C would equal 1, 2, 5/2. And then all I need to do now is put together my equation of plane C. So my equation of plane C will look like 1 times x minus, what was the point I wanted you to go through for plane C? 1 times x plus 5, okay, plus 2 times y minus 6, plus 5/2 times z minus, was it z minus 2? Z minus 2. Z minus 2 equals 0. Ding, ding, ding. And here we go. Now, make sure you understand, will Lindsay's vector n be the same as Oliver's vectors n? Be the same as Justin's vectors n? Be the same as Heather's vector n? No, because there are infinite possibilities for vector n in 3 space, not in 2 space, in 3 space, right? So yes, your vector n's may be different, and that is okay. But here is an equation of plane C. Very good, very good, very good, very good. Okay, let's do this now. Okay, here's what I'm going to ask you to do. I would like you to do this. Okay, plane Q is described by, okay, oh boy, 2x plus 5y plus 3z equals 4, okay? And plane R is described by 4x plus 10y plus 6z equals 1, all right? And plane T t is described by 2x minus y plus 3z equals 3. Okay, are you ready? Question number 1. I'll say it. Actually, I'm just going to pause me and then write it down and then replay me. Alrighty, here's the rest of your homework, and this is it. You have 2 questions. Number 1, find the distance between planes Q and R. Okay, that's what we just did in class. Oh, but number 2, find the acute angle of intersection between planes R and T. I guess the first thing I should say is you have to make sure that in question 2 that R and T actually would intersect, okay? Maybe I should have asked you that, like, question sub 2, like, do planes R and T intersect? How do you know? Okay, well, I kind of gave it away. Planes R and T intersect, and please find the acute angle of intersection between those 2 planes. And that is it. And I look forward to seeing you tomorrow morning, as I always do. And please, good luck with this homework, and I'll see you then. Have a good evening.